Thank you everyone for attending my talk. I know it's right before lunch, so I'll try to keep it a little bit more entertaining, give a little bit of stories, add some context to it, and try as much as I can not make it dry. So my talk's title is Onix, Zero Day Initiative Ruined My Life. Actually, Zero Day Initiative did not ruin my life. We ruined some code's life or some component's life, and I'll get to that after. So a quick introduction. You guys know my name already. So I used to be a researcher a couple of months ago, and then I switched to management role. Basically now I'm getting to be an expert in Office, Excel, and stuff like that. Currently I manage the vulnerability analysis team, so basically my tasks are mostly dividing the cases, just making sure they actually go through the program. Have you guys heard of the Zero Day Initiative before? ZDI? Excellent. So ZDI is just a bounty program, hey. A bounty program where we buy vulnerabilities from external researchers and we check if they're exploitable or not. If they are, then we basically just offer money on it. We generate guidance or signatures for those vulnerabilities, and then we roll it into the Trend Micro product, specifically the IPS and other products. So currently I just manage the vulnerability analysis team, and basically I just make sure that the cases flow, nicely, and there isn't any delays. I do a lot of the Ponto on actually the hacking contest preparations and judging and stuff like that. And I'm also responsible for pricing most of these cases. So if you guys have any questions about pricings or selling vulnerabilities to ZDI or anything like that, please feel free to reach out after the talk, and I would love to talk to you. So let me ask this question. Who uses Acrobat Reader or Pro here? All right, so there's a lot of hands raised. So is it a safe assumption to say that whoever did not raise his hand used Foxit Reader? Foxit? Wow. Okay, I did not expect that. I personally use Adobe Acrobat and Reader inside a VM. Just saying. Okay, so it's relatively an old piece of software. It dates back to 1993. And it's probably the most widely used PDF reader out there. You can run it on almost all platforms, which is awesome. It has been improved over the time, and basically Adobe started adding a bunch of components, improvements, just making it pretty nice, huge software. It's really nice to use, but with all the development efforts and stuff like that that Acrobat added to it, it came with a huge and large attack surface, which makes it a really interesting target for researchers and exploit developers specifically. The architecture has not changed in time, so it kind of maintained its architecture. And basically, I divided the architecture of Acrobat or Reader into 3 components, which is the core, and technically that's Acrobat or AcroRD. So Acrobat is the paid version of Acrobat, the PDF reader, which is Acrobat Pro or Acrobat Pro DC. It comes with a lot more components, and it basically allows you to do a lot of creation, editing, adding forms, and all that kind of stuff inside the PDF. And there's the free version of it, which is the reader, which is AcroRD 32, and that's what most people actually run on their computers. So the core is Acrobat or AcroRD, DLL, and EXE. So basically that's where the core application is. And then Acrobat supports something called plugins. So if you go inside your program files, Acrobat directory, then you're going to see a directory called plugins. And basically plugins are just simple DLLs, but they don't have .dll extension, they have .api extension, right? And every plugin represents different components. So for example, eScript, the plugin, is responsible for all the JavaScript stuff, which is what we're going to talk about in a minute. Catalog is a component that deals with, combining PDFs together and creating indexes for them, for searching purposes and whatnot. HTML to PDF is a component that converts HTML file to a PDF file. And interestingly, that component relies on WebKit AG, which is a WebKit engine that's inside Acrobat, and as you can guess, it's an old WebKit engine. So basically, it's still vulnerable to a lot of the old WebKit bugs or anything of that sort. I mean, there's a lot of plugins. Another plugin that I actually want to mention is Acroform, and we've seen a lot of vulnerabilities inside that plugin, and that's specifically responsible for XFA parsing and stuff like that. The back end is just the DLLs that does all the processing. For example, AXSLE is a DLL that's responsible for XSLT parsing. And a fun fact is that that DLL is basically a spin of an open source project called Sublotron. Have you guys heard of Sublotron before? It's an XSLT parser, open source. It hasn't been maintained since 2010. So basically, Acrobat grabbed that project, compiled it, threw it there, and we've seen a lot of bugs in it over the years. So what we've actually started seeing as well is people going back to Sublotron, auditing that code because it's open source, and then just, if they trigger a bug in Sublotron, it's automatically a bug in Acrobat, which was quite fascinating. Because Acrobat did not touch the code, they did not actually audit the code. They just compile, threw it there, run it, and even they added a JavaScript API for it, so you can hit it from JavaScript, which is sweet. CoolType is responsible for the font parsing, so all the font parsing that you see inside the PDF goes inside CoolType. JP2K lib is basically responsible for all the JPEG 2000 parsing, and which is quite interesting because you can actually hit that code through JavaScript, and basically if you just want to do like file parsing, just drag and drop or convert a JPEG 2000 image to a PDF, then you can actually trigger that code. So basically you have multiple ways to trigger vulnerabilities inside the JP2K lib. And we're going to talk about this guy after. All right, so vulnerabilities through ZDI. So back in December 2014, we were kind of having a meeting inside the ZDI, and we were like, well, we're not actually seeing a lot of vulnerabilities in Adobe and Acrobat. And it seems once Adobe rolled in their sandbox, I think it was like 2010, a little bit after that, and we started seeing, the vulnerabilities in Acrobat getting, we didn't actually see much vulnerabilities getting in the program that targeted Adobe products, specifically Acrobat and Reader. So we wanted to actually have a look at that product, see how strong it is. So we launched an internal project which was specifically targeted at Acrobat and Reader, and basically to find as much vulnerabilities as we can in that application. So first, I started targeting JavaScript, which was the easiest, entry point for it. So you can just go through the JavaScript API they have, and start, writing your own targeted fuzzer, start, calling random APIs. And frankly, I was super surprised that we found a whole bunch of, vulnerabilities, every freaking vulnerability type that you guys can think of. Use after freeze, heap overflows, type confusions, all the freaking vulnerabilities. Then we published a whole bunch of vulnerabilities back in 2015, and ever since we published those vulnerabilities, just blossomed. Everyone started looking at that application. And as you guys can see, it's in a steady increase. And every year we see more vulnerabilities, targeting more components inside Adobe, even components that you would never think of, and they would actually target it, which was quite fascinating. Actually, one thing I want to add is that in 2019, things got a little bit slower. So now we published 110 vulnerabilities so far in 2019 that targets Acrobat. We still have a lot more in the queue waiting to be patched, but I'm expecting it to be a little bit lower than 2018 this year. Which is an accomplishment, to be honest, for Adobe. So, all right. So let's talk about the attack surfaces and JavaScript specifically. JavaScript has a really sweet spot in my heart, so I always have to start with it. So basically, it's let's go back to the architecture. From the core, the plugin responsible for doing all the JavaScript parsing is eScript. And through eScript, you can actually hit every single DLL. So this one is technically not true. You can still hit it through eScript, but it requires a little bit of work. Specifically with the way you actually call the JavaScript APIs, which I'm going to get to the privileges after. So a little bit of an overview. Adobe has, or Acrobat has, a JavaScript engine inside it, which is a spin of SpiderMonkey, Mozilla SpiderMonkey. It's an old version of it, and they kind of maintain their own spin every time. Every time they get bugs, they basically patch their own engine. They don't rely on Mozilla to patch their bugs, they patch their own things. So basically, a lot of the APIs that you guys are exposed in the Pro version do not exist in the Reader. And some of the ones in Reader basically do not exist in the Pro version. So basically, you have to pick your battles here if you want to audit Acrobat or if you want to audit Reader. So most of the APIs are technically documented. And speaking of documentation, there's a website that Adobe has basically called the Adobe SDK, Acrobat DC SDK. Basically, you can go and check what every object inside Acrobat exposes, like methods and properties. So this has been known for some time. So if you guys are familiar with Collab, basically it deals with collaboration. So if you want to send a PDF, if you have like a group and if you want to send your PDF with other people to kind of add their comments and stuff like that, that's called collaboration. And that's what that object is responsible for. In the documentation, they documented 3 methods only of Collab. With a little bit of fact checking, basically Collab contains 128 functions. And basically they only documented 3 out of 128. Don't get me wrong, they actually got better. It was 137. So, and a lot of those and the ones that he actually killed were super devastating that they allowed you to actually drop files, delete files, and stuff like that. So they ended up cutting all the rest of the functions, which are undocumented as well. And now we end up with 128 functions. So let's talk a little bit about privileges. So JavaScript APIs, they're not going to allow you to actually run every freaking API you want, right? It's a little bit dangerous. Some of the APIs allow you to do interesting things, right? Like open a web page, possibly drop a file, save a file, I don't know, like a bunch of stuff. So they created this kind of privilege separation or contexts. And now you end up with functions that are privileged, or I don't have that here. So basically, in the API documentation, if you see a method that has a red S next to it, it means it's privileged. And by that, it means you need to increase your privileges when you want to execute that API. Normally, when you open a PDF document and it has JavaScript inside it, the JavaScript are being executed under the doc privileges, which is the current document that you have open. But if you want to increase your privileges, you have to execute your API from the root privileges, which is basically you have to bypass API privileges, and it has to be a trusted function. By trusted function, it basically, if it's a trusted function, then it increases the privileges that it has. And if it's a privileged API, then it has to be wrapped between begin priv and end priv. So in a nutshell, you have 2 types of API, privileges and non-privileged, right? The privileged APIs technically allows you to do more interesting things. The non-privileged are just the normal ones. And this is pretty interesting because a lot of people actually audited the JavaScript API, but they audited the non-privileged JavaScript APIs. They did not actually touch the privileged JavaScript APIs. To do that, you actually need a bypass. And we published like a huge research about what you can actually accomplish if you bypass privileges in certain APIs. It turns out that if you actually can do that, then you basically can technically get code execution in a logical way. So if you can chain an API bypass and call certain functions in a certain way, then you can technically gain code execution through a logical chain, which is very devastating when it comes to products like Adobe. We even were joking around back when we found the bypasses in 2015, 2016, and we were like, whoever was actually writing exploits, memory corruption exploits for Adobe before the render, before the actual sandbox was introduced, was wasting his time. Because you can actually get code execution just through logical chains, which was quite amazing. So let's talk about new attack surfaces. So everything that I talked about when it comes to JavaScript is a known attack surface. But for me, from an attacker, if I want to find something, a new attack surface, then I actually want that code that I'm actually reaching or I want to hit to be triggered through JavaScript. And that's for multiple reasons. Well, from an exploitation perspective, if you want to control a certain heap overflow or an out-of-bound rate, and if you have access to JavaScript, then it's game over, right? You can control how the memory is being laid out, heap sprays, and all that kind of stuff. That said, most of the attack surfaces that we've seen recently we've been getting through the program are basically file parsing issues. Well, JPEGs, whatever, HTML to PDF and all that kind of. Don't get me wrong, it's good, it's nice. I remember back in 2017, it was Chiho 360. They were participating in Pwn2Own, and basically they hacked Adobe Acrobat through a JPEG 2000 heap overflow. And basically it was an image that was embedded inside the PDF, and they were able to trigger the parsing of the image through JavaScript, which is ideal because basically you can trigger the bug whenever you want, which is different from font parsing because font parsing is a little bit tricky, because if you embed a font inside a PDF, then whenever the document shows up, then the font parsing basically happens. So you cannot, per se, always control when to trigger the font parsing, but you can control when the image parsing happens, which is quite useful for an attacker, right? So, it's a little bit of background. So I think in 2018, I was preparing for Pwn2Own. Usually I go to Austin for the preparation before the contest, and I start setting up the laptops. And I was like, okay, so there's a lot of idling when setting up the laptops. So basically you have 10, 15 laptops just sitting there waiting them to install Windows or whatever. So I was looking at Acrobat, and I was like, okay, let me see if I can find a new attack surface. And one of the things that brought my attention was there was a lot of old DLLs in the Acrobat directory. So this guy got my attention. It's called Onix32.dll. And if you can check the timestamp, back then it was, when I saw this, it was last year, 2018, and I was like, what the heck is that? Hasn't been touched since 2015. So I did a little bit of, checked the properties, and it turns out that basically it's from LexTech International. So what's that? So basically LexTech is a company that's based out of the States, and basically they offer different solutions, multiple solutions. And one of the solutions is an indexing solution, which is called Onix. And surprisingly, Acrobat acquired that solution and integrated that solution inside their product since Acrobat 6. And if I'm not mistaken, Acrobat 6 was released back in 2003. So that makes it like it's been sitting there for 15 years, basically, right? And when I saw that, I was like, holy crap. So this is something, I've never seen bugs in it before. I searched the internet, no one has touched it. So it's technically an untouched attack surface, which is awesome. So how does the indexing, this is by the way from their website, and basically the way they divide the text, they divide text into records, just like a book, right? And basically if you want to, when you search for something, it's going to return the record that the word that you search for technically appeared in, just like how the book works. It's a pretty simple concept for indexing, but it's pretty fast. So when I saw that, I was like, so how would I actually reach that code? Like, okay, awesome, you have an old library over there, but if you cannot touch it, if you cannot actually trigger the parsing, then basically it's useless. So I stumbled across Catalog, which is, as I mentioned before, it's basically a plugin that allows you to, it takes a collection of PDFs and it creates an index for the PDFs for searching purposes. And I was like, okay, so let me have a look at that and basically let's see if I can actually trigger that. And the nice thing about it is that it has a JavaScript API, that plugin. So I can load that plugin from JavaScript and I can trigger the build or everything else from it. So you have to, basically you have multiple ways to create indexes. What I did is basically I did it for testing purposes. I created an index through the actual GUI of catalog, basically. I just gave it a directory that contains a bunch of PDFs, and I just like built, and basically it just generated a nice index file for me. But there's something off here. Basically what it did is created a file called a format.pdx, and it created a directory with the same name of the actual index, and it had 2 index files. The PDX file is technically just, it's very similar to a PDF file format, right? It's Adobe, so they kind of have everything similar to a PDF format. And the index file is what was interesting. It's binary-ish kind of file format, so which made it quite interesting for me, at least, because I can just like try to fuzz it and stuff like that. So now, since I actually have all the information that I needed, then it was time for me to start finding vulnerabilities, right? So 2 ways, basically statically, and that's the first way that I actually approached it. I went to catalog.api, I reversed it, I tried to understand how it was interfacing. It was calling the Onix, APIs. And in the end, I found out that all the index parsing happens inside one function, one giant function. One thing I want to note is that there are 2 types of vulnerabilities. The first one is in catalog, basically the way it's handling Onix APIs. And the other type is basically core Onix API vulnerabilities. And I was successful in finding both, and I'll explain how it was found. One notable bug is this guy. Can you guys spot the bug? Yes, no? Any takers? Okay. So basically, just this guy wraps. So you end up allocating a small buffer, and then you use data buff size to copy. Basically, it's just like a standard overflow. And by the way, this code, if you search for variants, it's all over the thinking place in catalog. So it's just like kind of copy paste all over. So this is the original file, very hard, right? And this is the POC. So this was the first actual way that I kind of approached the problem in finding vulnerabilities. I was able to find 2 vulnerabilities through static analysis. Then I was like, okay, so this is going to take a little bit of time. I don't have time for reversing the whole thing. Let me just go to fuzzing. And how many guys of you actually have fuzzed Acrobat? No one? Yeah, I would not recommend you doing that. It's a pain in the ass, frankly. Especially if you have PageHeap enabled. It's such a huge application that it's so annoying to fuzz in a fast way. Don't get me wrong, you can fuzz it, you can, feed it a file, kill it, feed it a file, kill it. It's very slow. But if you want to do it right, then basically you have to break down things into components, like fuzz components separately. And that's something I actually, I figured out after trying to do all the crazy things, like, well, how about fuzzing the plugin? No, it doesn't work. How about fuzzing the application? Very slow. Then I was like, okay, so let me do the Onix 32, kind of wrap it up, write a small harness for it, and see if I can fuzz it, directly. In order to do that, we have to understand how the API works, right? But luckily, LexTech had, sample code there. They even had proper documentation of every freaking API there. So I didn't even need to go reverse how the functions were being used inside the catalog API, rather than just go to the website and simply just understand the code samples that they have and basically just write my own harness. So this is basically the documentation. For example, this API just documents the arguments. They're even nicer, and they basically provided the Onix type and the actual C type. So basically, if you want to write your own harness, you have all the ingredients over there. So what I did is basically I have my own fuzzing framework. I wrote the small harness, and then boom, start fuzzing. So this is an example of my fuzzing framework. I call it binfuzz. And it's just like a dump fuzzer. Just check the speed compared to actually just spinning Acrobat. Room. So every one of those is just like a test case. And then you get a crash. Actually, this is the first crash that I got, and I was super freaking excited when I got that. This is the actual bug. So the bug is specifically interesting because it's a very rare type of bugs, right? So it was an internal overflow inside an object. I found that, and then once we disclosed the bugs in public, the catalog ones in public, Sebastian Appelt, who's a frequent submitter to us, actually submitted the same vulnerability, but he found it through WinAFL. And he was taking a different approach, which I'm going to talk about, which was quite funny. So specifically, that vulnerability is an overflow. Basically, you overflow an object with a counter. Initially, when I found this vulnerability, it was always crashing in the same place, dereferencing the same value. And I was like, is this exploitable or not? Then I figured out that if I actually replicate the object, then I can actually influence that counter. And I kept replicating that object again and again and again. And basically, I ended up with this nice crash. But frankly, the index file was like freaking 10 MB. So it was so freaking huge. But I was actually able to demonstrate exploitability or control of that bug. So I'll talk a little bit about the patch because it's quite funny. So basically, we sent that to Adobe, and I'm not going to talk about it. I'm not going to burn the disclosure story because it's awesome. I'll talk about it after. But what they did is basically they added a small magic value and just small check. And when it was released, Sebastian sent me a message. He was like, well, I have a bypass for this vulnerability. I was like, holy crap, really? And it basically took him a couple of minutes to run another fuzz run, and then basically he was able to trigger the bug again, which was awesome. All right, so let's talk about disclosure, which is, I think, for me, it's one of the most interesting things. So when I found all the catalog vulnerabilities, I also found that bug through fuzzing, and it was in the core Onix API. I actually found two vulnerabilities. The first one was a heap overflow. It was that, and they use after free. So we sent all the vulnerabilities to Adobe at once, right? And it happens that they managed to patch all the catalog vulnerabilities. And they also got back to us. They were like, well, we also patched the Onix vulnerability that you sent us, which is the heap overflow. We could not trigger the use after free. And I was like, okay, let me check. And basically what they did, they disabled the build API, which I was using to trigger the parsing, but they did not actually patch the Onix 32 DLL vulnerability. The reason for that is that they don't really own the code. So basically, they only own the code of catalog. So it was easier for them to roll a patch. And they were like, okay, let's try to mitigate this and just kill the build API. Now he cannot trigger the parsing code. I was like, okay. Then it turns out they actually just killed it through JavaScript, but if you do it through the GUI, basically the GUI that I showed that you can build, then you can actually trigger the bugs again. So I sent the bug again. I was like, well, this is not true. You can trigger it through 1, 2, 3. And they were like, oops, okay, so we're going to have to send it to Lexstack, right? They sent it to Lexstack, and they got back to us. They were like, listen, you cannot actually trigger the vulnerabilities anymore, only through the GUI, which is fine, but we don't really consider that a high priority. So would you guys stop looking at that component and stop sending us vulnerabilities? I remember we actually had a call with Adobe, and they were like, we're going to send you an email documenting every way that you can actually trigger the parsing. And I was like, fine. So they sent us this big-ass email, and they documented everything. Like, okay, so catalog, you cannot do it. Search API, you cannot do it. I was like, okay, but I haven't been looking at the search API. But it turns out that this guy actually was looking at the search API. Funny enough, they documented every single case that you can hit the parsing code through query, but they actually forgot, or I don't know if they actually know, that you can trigger the parsing code even from a non-privileged context if you add an active doc. And an active doc is basically if you have that index file embedded inside the PDF, and if you run a search Acrobat active doc, then you can definitely trigger the whole code again. So basically, whatever they tell you, not true, not true. So this is what Sebastian did. Basically, he was approaching the whole research from the search plugin in Reader, and I was approaching the whole research from the catalog plugin from Acrobat. He even did it better, right? Because he was able to hit Reader, which is more valuable from an attacker's perspective. That said, he was like, well, Abdul, I have like a bunch of vulnerabilities. I was like, do you have a bypass for that? He's like, yeah, I have a bypass. I was like, yeah, send it. So we sent everything to Adobe, and we ended up with a bunch of vulnerabilities. He even found a user after free that they couldn't trigger, and he sent them a better test case than mine, which was awesome. I admit defeat on this one, which is fine. So in the end, Adobe, we had a call with Adobe again, and they were like, listen, we sent those vulnerabilities to LexTech, and LexTech got back to us, and we think that they're going to take a little bit more time to patch them. I was like, okay, so they're like, well, we decided to just kill the whole thing. And basically what they did, they ended up disabling it from the registry. So if you want to enable the Onix 32 parsing, index parsing, then you have to enable it from the registry, which was nice and not nice at the same time, because you actually have a vulnerable component sitting in your software if you actually enable that from the registry. So to wrap things up, I actually added this slide this morning. So honestly, Adobe is doing a good job in being more proactive with security matters. I mean, they added CFG, right? They compiled everything with CFG, but there are a couple of modules that are still not compiled with CFG, so I don't know if that really counts or not. Acrobat by itself is a huge software, a lot of components, and Adobe keeps adding more components to it, so it makes it a really interesting software to audit. If you want to add third-party components to your software, I mean, yeah, it's awesome. Third-party components can make your life easier, but yeah, they come with a heavy, heavy security price, right? And with that, any questions? Oh, crap. Yeah. Don't embarrass me so much.
So one of the arguments against bug bounty programs and vulnerability disclosure is that the vendors kind of lay back on the QA, trusting in other people to fix their bugs. I would like to add that to the fact that Adobe has been around for a very long time, and every time they send out a patch, it's like 80 vulnerabilities.
Yep.
So I kind of, if you can go one slide back, I was wondering if I could challenge your first sentence that said that they're doing a good job in security of their products, because one could argue that what they should have done a long time ago is do a complete code review, at the very least.
Right, so one thing I want to mention is that the reason why you would see 80 vulnerabilities is that they patch quarterly. So basically every 3-4 months they release a patch. So they don't do it like Microsoft every 2 weeks, the second week of every month. This is the first thing. The second thing, when I say about, well, they're being more proactive about security, you would be surprised how many components they actually disabled. HTML to PDF is still there. XPS to PDF, they disabled that. They killed that. Anything that actually has a lot of vulnerabilities and it's not super critical for them, they're actually killing the whole thing. And plus, they're trying to add mitigations. Okay, so it's not, it's not ideal mitigations. For example, CFG, they did not enable it for all the modules, so you can still bypass it somehow. But they're trying. And I've heard they're actually trying to roll more mitigations, like heap isolations and stuff like that, so they can minimize the exploitation of use after freeze and stuff like that. So I would give it to them, but they still have a lot of old code. Rewriting that is not the easiest. So it definitely requires rewriting the whole application, and I don't know if they actually want to do that, right? So this is my take on it. I'm trying to be positive.
Okay, we have another question over here.
This is more likely a question to the audience. Why there are so many users of Adobe Reader if you can read PDFs with Chrome easily?
That's a good question, actually. I can answer that for you.
Okay.
So Chrome, basically, if you want to create PDFs, do PDF editing, you cannot do it in Chrome. Second, PDFium in Chrome supports JavaScript as well, right? And it's a spin of, well, basically it uses Foxit SDK initially. It definitely disabled a lot of APIs. It's way more secure than Acrobat, don't get me wrong, when it comes to JavaScript, but it doesn't expose a lot of attack surface. Plus, you cannot do much with it. You can only read documents. For people who actually want to edit documents and send it and do a little bit more automation in enterprises, this is not a good solution, actually. It's a good solution for end users who don't want to do much with PDFs, which I understand. But if your business relies on PDF editing or stuff like that, then you got to find a better solution for that. Frankly, I had a look at PDFium. It's pretty nice from a JavaScript perspective, at least. Any other questions?
Does anybody else have a question?
Sweet.
No.
So feel free to reach out to me. I'll be around.
Okay. Abdul Aziz, thank you very much.
Thank you.